There's a population of 5 people and the sample of 3 people. If you want the mean absolute deviation of the population, first you have to find the mean of the population, which is the mean of the data column. You add these 5 numbers and divide the total by 5. The mean comes out to 14. You subtract all of the data values by the mean of 14 right here. The answers are the deviations. You leave off the negative signs, so all the numbers become positive. And these are the absolute deviations. You add the 5 absolute deviations, meaning you add the entire column, and you divide by the number of numbers in the column. There's 1, 2, 3, 4, 5. So you divide by 5. These numbers add up to 12. So 12 divided by 5 is 2.4. All this is the mean of the absolute deviation column. To get the mean of the absolute deviation column, you add the absolute deviations and divide by the number of absolute deviations. There's 5 of them, which is why you divide by 5. If you want to find the mean absolute deviation of the sample, well, first you have to find the mean of the 3 data values in the sample right here. I add these numbers and I divide the total by 3, since there's 3 numbers in here, and the mean comes out to 12. So 12 is the mean of these 3 numbers in the sample. Remember, when you're finding the mean of the sample, meaning when you're finding the mean of these numbers in here, don't use n minus 1 yet, because n minus 1 doesn't come, you don't use it until later. Right now we're just adding the 3 data values and dividing by 3. We get the mean of 12. We subtract each of them by the mean of 12. The answers are the deviations. If you leave off all of the negative signs and just use positive numbers, you get the absolute deviation column. The mean absolute deviation is just the mean of the absolute deviations. So add the 3 absolute deviations and divide the total by 3, since there's 3 of them, and that's your answer. It comes out to 1.33. So this value right here, the mean absolute deviation, is calculated the same way regardless of whether it's a population or a sample. We followed the same steps both times. If you want the variance and standard deviation, then that's when you use a different formula for population and sample. If it's a population, the first step is finding the mean of the data column. Add the 5 numbers and divide the total by 5. You get the mean of 14. Subtract all of the data values by the mean of 14. The answers are the deviations. And if you leave off all of the negative signs, like we did here, it's the absolute deviations. Multiply each of these absolute deviations by itself. So 4 times 4 is 16. 0 times 0 is 0. 2 times 2 is 4. We're just squaring all of the absolute deviations. 4 times 4 is 16. 2 times 2 is 4. And these become the squared deviations. You would get the same answers if you squared the regular deviations, because negative 4 times negative 4 is 16, but it's easier to square the absolute deviations because you don't have to deal with the negative numbers. If you add the 5 squared deviations in this column and divide by the number of squared deviations, which is 5, you get the variance of 8. So all the population variance is the mean of the squared deviation column. Just like how the mean absolute deviation is the mean of the absolute deviation column, the variance is the mean of the squared deviation column. And it came out to 8. If you take the square root of the variance, it becomes a standard deviation. So this would be the population variance. This would be the population standard deviation, the square root of 8. So standard deviation is just one step further from the variance. If you want the variance and standard deviation of the sample, find the mean of the data, add these three numbers and divide the total by 3, and the mean comes out to 12. Subtract each data value by the mean of 12 and you get the deviations. Leave off the negative signs and you get absolute deviations, like we have here. If you square each of these absolute deviations, you get squared deviations. So multiply each of these by itself. 2 times 2 is 4, 0 times 0 is 0, 2 times 2 is 4. Now we have the squared deviations. What we do next is, well, remember before when we found the variance of the population, it was just the mean of the squared deviations. This time it's almost like finding the mean of the squared deviations, except we don't divide by the number of numbers, we divide by one less. So it's like we're averaging the squared deviations, but it's an adjusted average, where it's one less than the number of numbers. So there's 3 numbers, 1 less than 3 is 2. So we add the 3 numbers and divide the total by 2, which is n minus 1, 1 less than the number of numbers. The top adds up to 8. 4 plus 0 plus 4 is 8. Divided by 2 is 4. This is called the sample variance, which is just the variance of our sample. And just like before, over here, you go one step further and take the square root of the variance, and you get your standard deviation. Square root of 4 is 2, so that's our sample standard deviation.